Hi everyone, I'm Toby from CMU. It's my great pleasure to talk about our work in privacy-preserving script sharing in GUI-based program by demonstration systems. This work is done with my colleagues Jingya, Chen, Brandon Canfield, and Brian Myers. Program by demonstration, or PBD, is an important approach to support end-user development of task automation, where the users create task automation scripts by demonstrating the desired behaviors on GUIs. The work we share today builds upon our mobile PBD system SIGCHI, which empowers users to automate arbitrary tasks by demonstrating on third-party Android apps. One useful feature for users is to share and reuse their demonstrated scripts. However, prior research has shown that the fear of leaking personal information is the main barrier that prevents the users from script sharing. There's an important difference between PBD and conventional programming. In PBD, instead of the user authoring the scripts directly, an agent observes the user's demonstrations, learns from these examples, and synthesizes the script. The agent often sees personal information during the process, and the users have little control in what's embedded in the script. There can be different types of personal information on app GUIs. For example, red circles indicate explicit personal information, such as the user's name and home address. There are also implicit types of seemingly innocent information, such as a person's usual order, favorite teams, and the nearest Starbucks store in blue circles. While they cannot be directly used to identify the user on its own, one can combine multiple pieces to identify the user. Let's look at where personal information may get included in the scripts. The first is called data description, which is how the system records a demonstrated action. For example, let's say one step in a demonstration is to choose an account. This action, as shown on the right, is recorded with the account number included. The second place is the context where the action is demonstrated. Recent PBD systems, such as SIGCHI, record the context of actions in order to handle execution errors, generalize procedures, and infer parameters. For example, when the user demonstrates clicking on the item iced coffee, the system also records the contents of the rest of the menu in order to parameterize the script. Based on the insights, we identified these four design goals for our system. And we came up with the uniqueness-based measure to identify likely personal information. The formal definition can be found in the paper, but the high-level idea is how likely that a different user of this app would have seen the same information on this screen. For example, if it's an account number, likely there's only one user who has ever seen it in the My Account page of an app. We built a system named Pinolite, which is named after a type of rock but also an acronym. The first component of the system is background data collection. It collects the content, screen, app, triple entries in the background from many users when they use the phone normally, and uploads the hashes of them onto a central server. The hash function uses a server-side sort, so attackers won't be able to compute them offline. When an author of a PBD script tries to share the script, the system first uploads the hashes of all the information entries. The server computes the uniqueness of each information entry and returns them to the author. The author will see the result on what information should be masked from the script, but they can also manually mask or unmask the information using this interface. After the author confirms, the script will be uploaded to the sharing server with personal information masked. Let's then look at the script consumer. When they run the script and encounter this step, the system first tries to use a hash to match what's on the user's current screen, but most likely it will fail unless, for example, the script consumer has the same account number. But then, the system will leverage the screen layout structure to infer the script consumer's local equivalent for this value. The same screen in the same app will likely have a consistent layout structure across users. Therefore, the system can find the account number of the script consumer based on the layout and use its value to replace the hash in the script, essentially adapting the share script with the consumer's personal data. That's how our system works from a high level. You can check the paper for the details. Our first evaluation question is, how accurate is our approach? We tested our system with 15 scripts for common smartphone tasks. As we see, our approach achieved a perfect recall. That is, it did not miss any personal information, which I think is the most important thing for a system like this. We ran a user study with 16 participants to investigate two additional questions. Can users understand scripts processed by Pinolite? And are users comfortable with sharing scripts using Pinolite? The results were mostly positive. You can look up the paper for details. That brings us to the end of my talk today. This work is a part of our SIGCHI project on programmable intelligent agent. You can find the other papers here. By the way, I'm on the job market right now, so hit me up if you know a position.